So now that we've defined the Argand diagram and we know how to plot a complex number, we're going to look at some geometrical interpretations of adding and subtracting complex numbers. Before we do that, let's review vectors because we're going to represent complex numbers as vectors. So here we've got two vectors A and B, and these are just normal vectors that you're used to from normal maths. So A is the vector 2, 3, and B is the vector 5, 1. So if we were to add these two vectors together, the geometrical interpretation of that is that's the vector that's equivalent to doing A, going along A, and then at the end of A, bolting on that vector B. So if we draw in that vector B, we're going to go along like that, and we'd end up there. So that's our vector B. So overall, this vector A plus B is going to be the vector from here, where we started, to where we ended up. So it's kind of like that vector there is the vector A plus B. So if we were to add these two vectors together, we'd obviously have 7, 4. Obviously the order of addition doesn't matter because we could have done B and then moved along by A, and that would have got us to the same place. So our vector A plus B would have been the same. Next, let's remind ourselves what the interpretation of A minus B is. I sometimes think about this as, actually I write it as minus B plus A. So the way that you can interpret this vector is if you start at the end of B, you're going to do minus B, which is B but in the opposite direction. So we're going to go along the B vector in that direction, and then we're going to do the A vector, which will get us up there. So we've started at the end of B and we've ended at the end of A. So we've done that vector there. That vector there is A minus B. So A minus B is the vector that takes you from the end of B to the end of A. That's assuming that both of them start at the origin, obviously. So let's look at an example of using this but with complex numbers. So we've got two complex numbers here, and let's draw them in the Argand diagram. So we've got our real axis and our imaginary axis, and let's plot 4 plus I. So 4 plus I is somewhere here. The real part's 4 and the imaginary part's 1, so that's Z1. And Z2 is 3 plus 3i. So we're going to go to 3, and we're going to go up to 3 here. So we've got our complex number Z2 here. The way that we're going to think about these complex numbers is vectors. So we can represent Z1 as the vector from the origin to the point Z1, because we can kind of think about Z1 as having the coordinate 4, 1. And Z1 is really the position vector of that coordinate. Kind of think about it as a vector. And similarly, Z2 is the vector that starts at the origin and goes to the coordinate 3, 3. So we're going to think about this using the position vector. So if we wanted to do Z1 plus Z2, let's just work out what Z1 plus Z2 would be without using vectors. So Z1 plus Z2 would be 4 plus I, and then plus 3 plus I, or 3 plus 3i. So what we're going to do there is we're going to collect together the real parts, which is 4 plus 3, which is obviously 7. And then we're going to collect together the imaginary parts. So we've got 1i plus 3i, so we get plus 4i. Well, if we represent these complex numbers using vectors instead, so we kind of think about the position vector of Z1 is 4, 1, and the position vector of Z2 is 3, 3. Then actually, we could add these two vectors together and we'd get Z1 plus Z2 would be 4, 1 plus 3, 3. So if we add together these vectors, what we're basically doing is we're going to add together the real parts. So we've got 4 plus 3, so we get the real part is 7. And then we're going to add together the imaginary parts, so we get 1 plus 3, which is 4. So you can see that that is basically what we did there, just using vectors instead of I. So we know that z1 plus z2 is 7 plus 4. We can interpret this using vectors as well, because we know that if we add two vectors together, we're going to travel along z1, and then we're going to add on, let's make this one green. So once we've gone along z1, we're going to add on the vector z2. So we're going to add on that vector there. And we're going to end up over here. So this is our vector that got us to z2. And then that point there is going to be 7 and 4. So that is 7, 4. Obviously, you could also have gone z2, the vector z2, and then add on the vector z1. So we're going to move interchangeably between representing a complex number in this form and think about a complex number in vector form.